everyone. I'm Satyarth, computer systems engineer at Lawrence Berkeley National Lab, and I wanted to present a simple concept work that aims to build a wrapper system to streamline import processing and export of data across data centers. A fairly straightforward application, but worth pointing out how Globus APIs make it super easy to do all the heavy lifting. I will walk through the challenges with the vanilla approach and how leveraging Globus APIs helps build a more reliable solution. Uh, as I said, we want to streamline import, processing, and export of data across data centers. That means we should be able to take data as input from anywhere, process it, and put the results anywhere across different data locations. So the input here would be the source data location, the destination data location, and the compute function that needs to run on the data. The application that I'm explaining, it's fairly simple, but implementing it from scratch would significantly increase the development time and the efforts. So before diving deeper into the pipeline, I can talk a little bit about the surrounding specifics. So the vanilla implementation was deployed on the NERSC spin systems. For a smaller implementation where either data is limited or a one-time execution is needed, it can potentially be deployed on a compute node that has access to both the source and destination directories. But the intended application is to automate the program where it can keep watch on the source location and execute the pipeline whenever the new data is at the source. One could either use file triggers or run the pipeline periodically, quote unquote, sweep all the new data. The code is executed on spin using containers and uses NERSC as the compute node for processing the data. On the left is an example of how we define Globus flows that correspond. The left side dia is an example of just transferring and computing data. The flowchart on the right shows a sequential implementation of the pipeline. It assumes file triggers for continuous execution. Going over the flowchart once, the file trigger keeps watch at the source location and initiates an import transfer as soon as any new files show up. These are imported to the temporary input holding location within the compute node. The compute node runs the processing function on all the files within the temporary input holding location and generates corresponding outputs in the temporary output holding location. Once this is complete, it initiates a cleanup process where the processed files are removed from the input directory and the outputs are exported to the destination. Once the export transfer is complete, another cleanup process clears up all the temporary output directory files. Also, at each stage, updates are made to the record-keeping database to make sure that no duplicate files are transferred or processed. Implementing this using Globus APIs requires registering flow of execution and compute functions with Globus. The data locations are identified within Globus as the collections and are assigned collection IDs to use them. Implementing the pipeline in this way has one major issue. Each stage can potentially be a single point of failure for the entire pipeline. Any execution can either break the flow or halt the execution at any particular stage. Uh, Breaking up the flow into separate, smaller microservices can address this. This would isolate each process, and any failure in any one module will not break the entire system. So this flowchart breaks the same pipeline into microservices, the imports, compute, and the export microservices. Each service keeps track of the progress using the record-keeping database, as mentioned in the last flowchart as well. Each service has its own separate triggers, which can either be the presence of new files within the directories, or we can look at the record-keeping database for updates to the files. In addition to this, each service can be monitored using Globus web portal and logs, which makes it a major convenience to debug modules in case of any issue. So in conclusion, this pipeline addresses automation of some of the mundane tasks, a very simple application. An example use case would be where a particular subroutine needs to run on every newly collected data, like where a data preparation subroutine needs to run to prepare the raw data for machine learning tasks. Globus APIs make it very comfortable to accomplish this. It can gracefully handle exceptions, handle parallel processing by utilizing multiple threads. Monitoring logs and web portals are a major convenience to keep track of the process. The current pipeline uses a very simple file database to keep a track of the record files. But to scale better, using a more robust database in the future can be more helpful. Thanks for your attention.